What is vector database? What is vector search? What is RAG? What is agentic framework? If you're someone who really want to understand all the basic concept, fundamental concept around RAG, around vector database, around embedding, this video is going to help you a lot. So in this video, I'm going to cover all the basic concept around RAG, around vector database. Okay, so let's get started, and please make sure watch this video till the end. This video can be a bit longer, but it is worth to watch this video till the end because I'm going to cover a lot of concept. Okay, so let's get started and let's understand RAG and vector database, how they are connected and how it is so powerful today. Let's get started. Before we talk about the basic concepts, first let us understand the database, right? If you're already working with databases like MySQL, like MongoDB, like Cassandra, like Oracle database, right? You're already using a lot of databases. Then why we need a vector database? And this vector database is a use case, especially in the machine learning, deep learning kind of application, in the AI application. Okay. So first, let me draw the comparison. What is the normal database, like relational database, and what is the vector database, and what are the additional capability that the vector database has and normal database cannot do that. Okay, so in the normal database, as you know, that we can put our data, maybe structured data and transitional data, and we can perform some query like using some keyword, we can get the result from the database, right? So this is the normal database like SQL, Oracle, this all thing. Then if already these databases are there, then why we need a vector database, especially in the machine learning application, right? See, let's suppose I'm giving one use scenario. Let's suppose you want to build a chatbot, okay, where you have multiple data. Suppose you have a website, right? And in that website, it has suppose 10 pages or 20 pages, and it is talking about all your details about maybe about your product, maybe about your company. It can be anything. For example, HR. Okay, suppose you have a lot of policies about HR, right? And you want to build a system where any user can interact with your system and they can get that detailed data about your HR policy, anything which you want to share with your user, right? So one approach can be, I can dump this all data which is related to HR or my website detail, whatever. I can dump the entire data into maybe suppose MongoDB or suppose Cassandra or suppose related database, right? But here, this database dumping is okay. You can dump the records in the tables. But the problem is these databases are not designed for performing this kind of search, right? It is not designed. The algorithms are not designed for. It can allow you to do like a word search or keyword search or some sentence search. Okay, it is not designed for that. So that is why, especially in the machine learning area, in the AI area, to allow user to build this kind of system, we have come up with a new technology. So vector database is a new technology where it allows the user developer to dump all the data. Suppose your website data, your HR data, any kind of data. Maybe it can be text, it can be video, it can be sound, it can be audio, it can be picture. It support all kind of data. You can just dump the data in database, okay, and you want to perform any kind of search over there. Let's suppose you have put all your HR related data, all the policy in the database, and your employee, your user want to perform some search. For example, what is the policy about this? Okay, how to do in this scenario, something like that. You have put all, you have a knowledge base. That's what I'm trying to say. So in this case, you have, suppose you want to build your own internal knowledge base and you want to build application around that. In that scenario, normal, or you can say relational database, will not fit into this picture. That is why we come up with vector database, where you can do a search against the whole bunch of documents, bunch of pictures, bunch of videos, bunch of sounds, right? This has not capability with the normal database. So that is why the vector database come into picture, and it's help you a lot to do a very complex search. Okay, So this is a basic concept about vector database. So in the vector database, there are some concepts. So first of all, let me talk about a couple of concepts. Okay. So I hope you understand what is vector database. So vector database is you can do a search. Okay. Beyond the simple keyword search, you can do synonym search. You can do actually finding what user means by query. Okay. And you get the, you can get the answer. This is very important concept in vector database. It's called semantic search. Okay, what is semantic search? So, for example, this is what vector database comes into becomes very powerful. Okay, so essentially it's okay. It only not only search by keyword. It search by similarity. This is very important. It search by similarity. Let me explain that. Let's suppose you have a text data. Suppose you have a cat. You have a kitty. Okay, see, these are two different words. Cat and kitty are two different words, but meaning wise, semantically both are similar, almost similar. Okay, cat and kitty are different if they compare letter by letter. Maybe word wise they are different, but meaning wise, semantic, if I do a semantic search, they are very close. I'm not claiming that they are exactly equal, but semantically we are very close to each other. Okay, so this kind of scenario we have, so that is why it is called semantic search. Okay, not a keyword search, it is called semantic search. So this kind of searches we can do in the vector database. Okay, so this is what it gives you a lot of freedom. Okay, and one more thing, there are a couple of concepts here I want to talk about in vector database. Okay, let's suppose I want to dump my all the documents, I want to dump my all the pictures, I want to dump my all the videos, and I want to perform some kind of search. I want to build my own knowledge base, and I want to build application around that. So that is why you have to use vector database that I discussed. Okay, so in this vector database, which there are a couple of concepts, couple of terminology that I want to cover here. For example, it has a vector search. I will talk about search in detail. Okay, and it has a concept of data ingestion, embedding, query. Okay, these are the basic concepts which are used in vector database. Okay, so let me explain how it works. Okay, so in the vector database there are two kinds of, you can say, we have to build two kinds of pipeline. Okay, so let me explain that pipeline. One is called embedding. How the vector database work? It works with the help of embedding. Okay, what is embedding, by the way? So embedding is a machine learning model. Okay, let me explain that. What happens? Vector database actually it works on the vector. Okay, what is vector? Again, if you know the mathematics, if you come from mathematics background, so vector is every vector. If you want to uh, explain any point in a space, we can use vector, right? So vector has a magnitude and it has a direction. Okay, let's suppose you have an x-axis, y-axis, and you have a two dimension like x, y, right? So you can express this any point in two dimension, in x, y dimension using vector. It can have some direction, it can have some magnitude. I'm not going to cover very detail in vector in mathematically. Okay, but logically this is the meaning of vector. So every vector has some direction and it has some magnitude, right? So what happens, this whole concepts, okay, this whole the vector database work with the embedding. Okay, what is embedding? So whatever documents or whatever sentence I want to put into database, it will not go as a raw database, as a raw data. Okay, so we have to convert those data, or maybe it can be image, it can be video, it can be audio, it can be text, anything. We have to convert into vectors. So this is the this is how it is different from normal database. Okay, let me give example. Suppose I'm sharing my code. I will explain that. Let's suppose this is my documents. Okay, just for sake of reference, it is a very small document. Suppose this is my document, right? I want to insert this document into my let's suppose vector database. Okay, so how to insert this? This whole lines, okay, this whole word or whole lines will be converted into vectors. So vector database, what they do, they convert your text, your data into a numerical data, because your machine learning algorithm, they understand about numbers. Okay, they work very good at the numbers. So this all lines I need to convert into a vectors, into multi-dimension. Okay, so how to do that? So that is why to convert all the documents into vectors, there's a concept called embeddings. Okay, so these embeddings, what they does, for example, suppose cat, suppose I want to insert cat. Okay, so this vector embedding, it's a machine learning algorithm. Okay, I'm not going to cover how it works, but it's a, let's suppose it's a machine learning algorithm which convert your text into a vector. So here, for example, this cat can be represented, I repeat, any text, any word, or any video, they can be represented in numerical terms, in terms of vector. For example, this cat here, it has been represented by this vector. Okay, and it has a multi-dimension, not only two dimensions. It can have 500, 600, 700 multi-dimensional data. So this cat is represented by this one, this vector, and kitty can be represented by this one. You might be thinking, who is converting this cat and this vector? Who is converting this vector, I mean this text, into numbers? Embedding, the algorithm. Okay, the I will discuss later. So but for time being, let's assume that there is some algorithm, there is some code, software or code algorithm which are responsible to convert this all text into numbers, into vectors. Okay, and you can see that what is the one thing, what is the benefit or what is the advantage of embedding is that if two words, I repeat, okay, just play pay attention here. If they are two words or two sentences, if they are logically same or they are semantically same, semantic wise both are same, maybe word can be different, but logically meaning wise both are same. Okay, in that case what will happen, the vector will be almost same, not exactly same, not ditto same, but the distance between the vectors in that case can be very less. You can see that, just for example here I'm showing that. So 1 point, for example, cat is represented by 1.5 and kitty also 1.5, minus 0.4, 0.4, 7.2, 7.2, 19.6, 95.5, 3.1, 3.2. It shows that these two vectors, they are two vectors. Okay, let's suppose it can be in some space. So this vector can be in a space, this vector can be a space. So both vector, the distance is very less because the data is almost same. Why it is happening? Because cat and kitty are semantically are almost same, not exactly same, maybe word wise they are different, but logically they are same. That is why the vector representation is almost same, they are very close to each other. So this is how the embedding work. Okay, so embedding, I repeat, embedding is a algorithm, is a machine learning algorithm which take care of converting your text, your video into vector for in the vector form. Okay, so it can be anything. It can be video, it can be clip, it can be image, it can be text file. Okay, there are a lot of embeddings available. For example, I'm giving one example. Let's suppose I have multiple words. I have a cat, dog, apple, strawberry, building, car. Okay, so suppose I'm injecting this all word into my vector database, right? So what will happen? First I need to embed it. Okay, and this all embedding will become as a vector, and this all vector will go into database, which is vector database. Okay, so vector database basically store all the embeddings along with the text. They store all the embeddings, and these all embedding are nothing but vectors, multiple vectors. Okay, so you can see there, you can see here cat and dog. Okay, because both are similar semantically, both are similar. So the distance between cat and dog, you can see the numbers are almost same, very close, very nearby, right? But see the cat and apple, just try to see the comparison. The cat vector and the apple vector, both are too far away. I mean, their distance is very far. You can see 1.5, 5.2, the distance is very far. Okay, so this way it represents the data into vector form, and you can easily find the distance which are logically same or equal, all the text. Okay, so this way, let's suppose I inserted this all data and I got all the vector. This all text has been converted into vector. And let's suppose I want to search fruit, right? So this fruit, this is my query. User is giving a query called fruit. I want to search fruit. It can be apple, it can be strawberry, right? This can be, because they are the multiple fruit in my database, right? I want to search fruit. So what will happen, this fruit which is a text, user is interacting with that text, okay? So internally this text will be again converted into vector, because in the database it is storing vectors, it is storing numbers, right? So if I want to perform a search, I need a vector again. So that is why the query again is uh, converted into a vector, a numbers, and then this vector will be searched against all the vectors which are in the database, okay? So your query vector which is coming from outside will be searched against all the vectors. So the database, it's an internal algorithm of database, the search algorithm. They try to find the minimum distance, okay? For example, you can see the apple and fruit, it is minus 5.2, it is 5.1, 3.1, 2.9. You can see that. So the apple and the distance between apple, strawberry and fruit are very close. They are very close in the space, okay. But let's suppose the fruit and building, just try to compare the distance between fruit and building. Building has this representation 60.1 minus 60.3, and fruit has the representation minus 5.1. So you can see the distance is too far away. So building representation, which is vector representation, and fruit representation will be very far away. There's no similarity. Okay, this is how the vector database internally work. They store all the text, all the information into vector presentation, into number presentation, and if any query coming up, they again convert it into vector, and database internally do the search again. This is all vector. They have multiple algorithm. Okay, this is how it works. So how to create embedding? So this is very important concept in vector search. You have a vector database, okay, and you need an embedding, and embedding is responsible to convert all the text, all the data into vector format. So for that we use a lot of embeddings. Again, it's a machine learning algorithm. There are a lot of people have done research on that, okay, to create embedding. It's a research topic, by the way, okay. So there are a lot of embedding. For example, word to vec. I'm not going to cover in very detail. It's again, it's a different topic, but there are a lot of transformation model like BERT, word to vector. Okay, you can just do research on this. Okay, so these are some research area. There are a lot of researchers who are doing research and then creating algorithms around that, and depending upon the media, whether it's a text, it's an image, it's a video, it's a sound, there are different kinds of embeddings depending upon their sources. Okay, so you have to use this embedding, right? So I'm not going to cover the embedding. So in short, embedding is a machine learning algorithm which is responsible to convert your text, your images into a vector. This is what you have to put the concept right now. Okay, so I hope you got the concept as of now. So what I wanted to cover, the data ingestion. Okay, embedding, I hope you got the understanding what is embedding. So I repeat, embedding is a machine learning algorithm which is responsible to convert your data into numerical form, which is vector. Otherwise vector database will not work. The whole idea, the core concept behind the vector database is this embedding. If you don't do embedding, it is not going to work out. Okay, this is the first part. Now in every application, suppose you want to do, you want to build any application around vector database. Okay, so you have to perform two operations. Basically there are two pipelines, you can say. Okay, the first pipeline is called ingestion. I mean, you have to, suppose you have a HR documents, you have a PDF, or you have an image, you have a videos, you want to put into your knowledge base, you want to put into vector database. So first thing what you have to do, you have to build a pipeline. Okay, and that totally depends upon your requirement, your business requirement, that how the data is coming into system, and this will happen continuously. Okay, let's suppose you injected one data today, and maybe tomorrow, after 1 day, 2 day, there are some new data coming up in your system. So again, that data will go into database, into vector database. Okay, so how it works? Okay, so suppose you, first of all, you have to create a data source. Where is my data source? Okay, and all the data will come into in this data source. It can be file, it can be PDF, it can be CSV, it can be image, it can be audio, it can be video, anything. Okay, or it can be a bucket. Suppose your data source in the cloud, suppose in the bucket or Google bucket or AWS bucket, it can be any place. That's what I'm trying to say here. And the data will come into this data source from multiple sources. Okay, So if you want to inject this data into vector database, what you have to create a pipeline, multiple pipeline, and then finally you have to create a chunk. Okay, so suppose this data, suppose I have a one PDF file, and PDF file has a size of suppose 5 GB. Okay, so this whole 5 GB size will not go into database. So first thing we have to do chunking. What is called chunk? Okay, so it is called chunk. We have to create multiple small chunks or a small size of documents. It is called splitting. Okay, so suppose I have a 5 GB of data. So this data will be, I will create a multiple small chunks. This is the first step. Okay, and for every chunks, let's suppose I got C1, I got multiple chunks, C1, C2, C3, like I got multiple chunk, right? So each chunk will get embedded. Okay, each chunk C1, C2, C3, we have to apply the embedding. There will be a layer, you have to build a program around that it will accept multiple chunks, and it will apply the embedding algorithms. Okay, and it will convert every chunks into a what? Vectors, vector v1, vector v2, vector v3, right? So every chunk v1, v2, c1, c2, c3, by embedding algorithm, they are being converted into vectors, which are nothing but the numerical representation in multi-dimension. And these vectors v1, v2, and v3, these vectors are sitting into your vector database along with your chunk, the real text. So vector database store both text and both your vector. Okay, so this is how the vector data work. So this is the first pipeline you have to build in JSON pipeline. Data will come into multiple sources, chunk it, split it, clean it, and embed it. You will get multiple chunks, multiple vectors stored into vectors along with the text. This is the first part. Okay, if this first part is done, I mean your data, your knowledge base is ready now. You got all the data is into vector database. Second part is called the query part, because now your database is ready, your system is ready, your knowledge base is ready. Any user can come and they can query something against your database, right? Because it's a very normal operation for every database. We have to perform query. So here, let's suppose this query will come into maybe text format, because this mainly these user humans, okay, they will interact with that text or some query. So this query, again, whatever you query coming from user side, they will again get embedded. Okay, why this embedding is required here? Because in your vector database, you having only the numbers or only the vectors, right? Suppose if I don't embed here and I'm getting the query, so the database engine, because database has only vectors and you're passing query and there's no embedding, let's suppose. So this query is a text format. This text format cannot be compared or cannot be searched against vectors, because your source is vector itself, right? So that is why I need to convert this query again into a vector. So I can apply the same embedding algorithm which I had used using the ingestion process. You have to use the same embedding. Okay, so this embedding I will apply, and this embedding again convert my query into another vector. So this, you can see this part, this blue part. Okay, so suppose this I'm representing this multiple, I have multiple vector. This is, suppose this is the v1, this is v2 vector. Okay, and let's suppose I got a query and this query got converted into another vector, query vector. Okay, so what the database engine does, so this database will take this vector, which is a query, and it will compare all the query against all the existing vectors which are in the source. Okay, and it will try to find the similar, I mean closest vector, I mean the distance is nearby, and it can be multiple vectors. Okay, because it can give you multiple documents or multiple vectors which are very close to your query vector. So you can ask database, key for this query I want 2 similar document, or I want 3 similar document, or I want 4 documents. So that's I can give an instruction while searching I can give the instruction to my database engine ki I want 2, 3, 4, how many similar documents I want, how many similar vectors I want. You can give this instruction. Okay, so this way a vector database do the perform the search. Okay, this is very, I'm explaining very simple way. There, this database use a lot of algorithms. I will talk about this in coming in some time. So they use a lot of algorithm for finding the right vector, which is very close to your query. Okay, this is all is done by vector database itself. They have internal query, internal algorithms. Okay, for demo, okay, I'm just showing one code here just for demo purpose. Okay, so here, let me go to the code here. So here I'm using OpenAI. Okay, I'm importing this OpenAI, and OpenAI has a lot of embedding, inbuilt embedding. I'm using one of the embedding. Okay, so let me explain whatever I discuss here. This concept, I want to explain with the code so that you will get better understanding how it works internally, right? So here, let me explain that. So I'm using OpenAI, okay, and OpenAI has its embedding model. I will use that, okay. And let's suppose this is my source. This is the document I have, okay. That I suppose this is my, suppose I have a website, and my website, suppose I'm running a coaching business and I have a website, and this is my document that I help people to become data scientists. These are all the different lines or different documents. Data scientist is a great job. There are many data scientists in the world. I take 2 batches of data science student every year, starting new batch of data science. This, or suppose I have multiple information. Okay, I want to first is what I discussed, right? The first part is the ingestion part, right? You have to inject into database. This is the first part. Okay, so here what I'm doing here. So this database, this whole sentence, I want to embed it first. I want to create into vectors. Okay, so for that this is my algorithm of small function which will create the embedding. Okay, so here I'm passing the model. These are the OpenAI model. This is the embedding model. So there are multiple models. There are multiple algorithms or multiple algorithms for embedding. You can use anyone. Okay. So here I'm using very small text embedding 3 small. Okay, I'm passing the text. Okay, and this will create an embedding. So my whole purpose is what I will take the sentence, suppose the first sentence, and I will convert into a vector into using embedding. This is what my whole idea is there. Okay, and then this is what I'm doing here. I have a dictionary where I want to store. I'm not using any database here. Just I'm using in the memory just for sake of demo. So I have a sentence vector. Okay, so in this dictionary, I want to store all the sentences, this sentence along with their vector representation. This is what I want to do. Okay, so I have a sentence which is a list. If you know Python, it's a list of string. So I'm looping all the sentence. Okay, and for each sentence, I'm calling the embedding function. So for each sentence, it will create embedding. It will call this function and it will create a embedding. Okay, and this embedding I'm storing into my dictionary. It's a very simple Python program. So I'm storing key is my sentence in the dictionary, and the corresponding value is the embedding itself. Okay, so this way I'm storing all the sentences. This is my ingestion part. Okay, now the second thing is suppose I want to search. Okay, and I told right how the database works. The search, it finds the closest vector. It finds the similar vector. The whatever query you are giving to database, it will convert the query into vector, and it will find the very closest vector which are very close to each other. So there are multiple algorithm. Again, database use multiple algorithm how to find the nearest vectors. There are multiple algorithms. So one of the algorithm I'm using here, cosine similarity. Okay, if you do a if you know the vectors, there are multiple way to find the distance between 2 vectors. Okay, you can do a search. You can find multiple way. There's a cosine form. There's a cosine way. There's a dot product. There's a Euclidean distance. You can find the distance. Okay, I'm not going to cover that mathematics part. So this function will give me the distance. Okay, the cosine distance between 2 vectors. So query vector, whatever I want to query, I told right. This query which is coming into system, that will be converting into vector. Okay, so that is what is representing a query vector. And the source vector is my sentence. This is my vector. So okay, so I want to search this query vector against my source vector. This is what I told right. This is what the database does. Okay, So this is what I'm trying to mimic here. Okay, so how to do a cosine search? Again, this is a formula of you can do a research. Okay, this is the formula for do cosine research. Suppose there are two vectors. Okay, so this is the formula. Let me write here. So how to two vectors? Let's suppose we have two vectors. Okay, so how to find the okay, so let's suppose I have vector 1 and vector 2, right? And I want to find the distance. So this vector can be, suppose this is x, I'm using two dimension. This is x axis, this is y axis. Suppose vector v1 is 1 here and vector v2 is here. They are two dots, 2 points. Okay, so this is the vector v1, this is the vector v2, right? This is the mathematical representation of vector. So I want to find the distance. So distance is this, right? So how to find this distance between two vectors? There are multiple algorithms. So one of them is a cosine. So how to find that? We do the dot product v1 dot v2. It's a dot product dividing by v1 the magnitude of v1 into v2 magnitude. It's a mathematical formula. It is called cosine. Okay, cos theta cosine formula. So this way it will give the distance between two vectors. Okay, I'm not going to cover in detail that concept. So this is what I'm doing here. So I'm doing np dot, I'm using numpy library here. Okay, for that you should know the Python. So np dot dot, so dot will do the dot product between two vectors. So query vector, source vector, I'm doing the dot product. Okay, and then dividing by the magnitude. So this np dot, I'm using linear algebra of np library using NOR. So this will convert a what is called magnitude of each vector. Okay, so this is a very simple formula. Okay, so this will give me the cosine of the distance. So now this is the main logic here. So here I'm getting a logic how to find the similarity. Okay, so suppose this is my query. I told, right, in the database, suppose you have done the ingestion, then the important is the query, right? So here user can trigger any query and they will try to find the record. So this is my query. Okay, so I told, right, the query again, it should be converted into embedding because in the data source you have all the embedding, you have all the vectors. So this query should also be converted into vector. Only then the database can perform the research. Otherwise, search is not possible. So that is why this source, this sentence, this query, I'm converting into embedding using the same algorithm. Okay, get embedding. One thing you have to note: the algorithm for ingestion, the embedding algorithm for ingestion, and the embedding algorithm for query, it should be same. Otherwise, maybe search will not work. Okay, so here I'm using the same embedding algorithm, and I'm getting the query embedding. So this query embedding nothing but the vector. So this query, whatever a user will give a query, this will be converted into a vector. Okay. And here, what I'm doing here now for each I want to do search. Okay, so for each sentences, okay, I have multiple. So this query, what I'm trying to do here, this query I want to search against all the sentences, which is the closest. This is what database does, right? So I'm running a loop of sentences. Okay, and for each sentences, so for each sentences I have a vector database, right? I already stored into sentence vector. In this dictionary, I have already stored what is the corresponding vector representation of my each sentences, right? I have already stored there, right? So what I'm doing here for each sentences, I will call cosine similarity this function, and this function will get the cosine of my query and each sentence. Okay, so I want to find the distance between this line and my query. So that is why this function is doing, and this way it will find the cosine, and here I'm just putting it. Okay, and this way I will so here what I'm trying to do here, I have a query converting into embedding, converting into vectors. I have a documents in database, all the sentences, and I have already embedded all the sentences, and I want to perform a query cosine search, similarity search against all my vectors, against all the sentences from my query. This is very simple logic. Okay, what I explain here, this is what I'm trying to achieve from the code. Okay, if you run this, okay, let's suppose now this is my query. Okay, so this is my data, this is my document, right? And in this document, I want to search when new batch of data science will start. Okay, so you can see that in my source document, I have some information that when I'm a starting batch. So I to take, suppose here, 10 April, I've written that, right? I am starting a new batch on this time, okay? And user want to search when the new batch is going to start, okay? This is what I want to perform. So this is my query, okay? If I run this query, okay, and let us see what will happen. So I have already run this. Let me again run this. Let me explain what it's doing internally. Okay, so this is my query, right? When the new batch of data science will start. That was my query, right? And this logic has done the search against all the sentences. These are my sentences in database, right? So it is trying to find the distance between my query and this sentence. So the cosine is giving me this distance, 0.48. Okay, so how the cosine work? The more value, the cosine value, the cost is between 0 to 1. Yeah, 0 to 1. Okay, so if it is tending more about 0, near 0, okay, then the similarity is more. Okay, so if the value is more, nearby 1, then I will assume that this sentence, this query is very close semantically to my document. Okay, so you can see here this line, you can see here which has the most maximum value. uh, this has the 0.62, 0.72, right? So it has the maximum value. So the distance between this line and this line is less. I mean, this query is very close, very nearby this line. So this data, this cosine data is giving this information that the distance between your query and the sentence is less. Okay, and if the cosine is less, the distance is very far away. So these two line, I can say that these two line, I take two batches because see, new batches, right? It has the batches, so it is matching batches, new batches. So that is why it is giving you very nearby. So I can make a statement that these two lines are very similar to my query using this data. Okay, so this is how the cosine work. Okay, so this is very simple. By the way, this what I'm explaining here, this whole concept, it is very simple way. Okay, but let's suppose it is not very. I would say in the production, it does not work like this. Okay, let's suppose I have millions of documents. I have a lot of images. Okay, so like this, doing the cosine, doing the search against all the document, it is not. I would say it is not a good approach, or it is not a performance wise, it is not good approach. Okay, so vector database, what the vector database does, okay, so vector database has their internal algorithm. Okay, they have their internal algorithm, they use multiple algorithm to how to find the nearest vectors of the query. Okay, I'm not going to cover that. So this is one of the simplest I showed, right? Cosine similarity. Apart from that, there are multiple databases which use very sophisticated or very advanced technology or advanced algorithm to find the search, to perform the search. Okay, and this is what, suppose you want to build your own vector database, you have to implement this search. Okay, so there are multiple algorithms. For example, if you know in machine learning, like knn, ann, like approximate nearest neighbors, it'll find the nearest neighbor. Okay, I'm not going to cover in that detail about this algorithms. You can find on Google, or you can again research it. Okay, but you don't have to actually, if you really want to develop some application, you don't have to go in that detail. It is the responsibility of database vendor, like vector database vendor. They have the responsibility to internally implement these all algorithms which I'm talking about, like tree clustering, hashing, proximity graphs. Okay, these are the multiple algorithms which database internally implement, and it gives you the find research. Okay, so this is how the vector database work internally. I hope you got a lot of clarity as of now. Ingestion part, chunking part, converting the text into vectors, and vector database store all the vectors, all the numerical presentation. The query comes, query again getting embedded, converted into vectors, and the search is the job of vector database. They had internal algorithm internally to find the closest or nearest vector, and it will give a list of document or list of chunk which are nearest to that your query. This is how the basic concept or basic logic of vector database. I hope you got that, right? There are multiple vector database. There could be multiple, depending upon your requirement. There are multiple search you can perform. You can do image search, you can do audio search, you can do video search, you can do multimodal search like audio, video, text, everything. It support all kind of multimedia, all kind of sources. Okay, you have to explore that how to do that. Okay, so this is what it does, the vector database. Okay, there are multiple kinds of vector databases. You can do a research on internet. There are multiple databases are there. Okay, like Chroma is there. I'm not going to cover that part. You just do a just do a Google search. What are different vector databases? You will find that. If you're using MongoDB, MongoDB also can work as a vector database. Cassandra can work as a database. Chroma is there. There are multiple database vendors. I'm not going to cover that. Okay, you can find that. And these all database internally make the search happen. They're using this internal logic to perform the search. You don't have to worry as a developer. You don't have to worry. These are the job of vector database. Okay. Next part here I want to cover. Okay, as of now, I hope you understand the basic ecosystem, basic concept of vector database, how it works. Okay. Now, next part I want to cover RAG. Okay, what is RAG system? Okay, so RAG, if you really want to build RAG application or agent application, multi-agent application, then you have to know these concepts, this vector database concept, which I'm talking about. These are the basic concepts. Okay, so how the RAG works? Let me explain what is RAG first of all. Okay, so RAG has, in the RAG application, it has three important process. Okay, first part is called retrieval. Second part is called augmented, and third part is called generation. There are three important parts. So let me explain how the RAGs work. Okay. So one thing, before us starting the RAGs, what is the use case? Let me explain the use case of RAG. Okay. So let's suppose you have LLM. You know that we have a lot of uh, LLM like OpenAI, like ChatGPT, like Olama, like DeepSeek. There are multiple algorithms. This multiple large language model, right? We have multiple LLM, and the beauty of LLM is that it can give you, it can perform a search. Okay. One thing here, the problem with LLM is that this LLM has been trained on horizontal data. I call it horizontal. Okay. So LLM is a horizontal technique. What is called horizontal. So LLM has been trained on multiple data. No doubt about it, right? It is a horizontal technology. But let's suppose I want to build a chatbot or suppose questions answer kind of platform for my internal system. Suppose I have a HR department. I'm giving example, okay? For HR department, I have a lot of knowledge base. I have my own data, HR data. It can be huge data, right? And I want to build application around, my case is that I want to build agents. I want to use LLM, agentic flow. I want to create multiple agents. And the best part is that that agent should get the data from my database, from my knowledge base. Because this is my personal data, this is my company data. Okay. So how to do that? So it's a vertical. So I would say LLM is a horizontal, but RAG is a vertical. Okay. So you are I mean, you are solving one business problem with respect to your data using agents, using AI, using LLM. Because LLM has a capability to do everything, like do summarization, do text summary, to find the answer, converting text to image. There are multiple cases, right? So depending upon your use cases, you can build multiple, you can solve a lot of problems. Okay. So here, that is where RAG can come into picture. Okay. So if you want this kind of system where you want your own knowledge base, and you want to create agents, and you want to integrate LLM, that is why RAG comes into picture. So RAG has three parts. Okay. First thing, if you really want to build a RAG application, what are the things architecture wise what you have to do? First thing, you have to inject data. Injection. Okay. I discussed, right? There should be an injection pipeline. This I discussed, right? This is the first part. So ingestion the same thing. Okay, suppose you have a document and you have to create the document into multiple chunks. Okay, and you have to use some embedding layer, embedding model, and these chunks will go into embedding and it will get converted into vector, into a numerical representation. So this part is the first part, is the ingestion part, which you have to do. Okay, second part comes the query part. I explained, right? So again, the query will again go to embedding. Again, we have to embed it because we have to convert the query into vector representation. Okay, and the database engine will accept the query. It will convert into vectors and it will perform the search. And how the search happen, I have already given the demo. There are multiple algorithms. So this vector database engine, they will find the closest documents or closest chunk of document which are matching semantically with the query using their internal algorithm. Okay, and it is called context. It got some context. Okay, suppose I got 5 or 6 chunk of data document from after the search. Okay, so you have a query. Now what is happening here, you have a query, and for that query you got context. You got chunk of data which are very similar to that query. Okay, and then you are combining the original query with the context and passing to prompt, and passing this prompt to LLM. So here you can see you got the query, you got the context from after the search, and you're combining this combining is called augmentation. Okay, retrieval is called search. You got the context from your query, and then you're combining into a prompt. It is called augmentation, and this prompt you are sending to LLM. Okay, so this LLM will get the context from this data, from this context. It will not only work on the horizontal, it will work on the vertical, because you're passing the context, you're passing the query, you're passing the context. Okay, this is how the LLM work, and finally it will generate the response. Okay, so this way you can solve a lot of business problem where you have your personal data, you want to train on your personal data, your model you want to train on your company data, personal data, and you can build multiple kind of chain of agents or agentic framework. Okay, you can create multiple agents. You can create your own knowledge base where you can get the context, and this context you can pass to your model, your LLM framework, and they can get your response, and you can solve a lot of problems. Okay, so RAG, if you really want to implement RAG, so this concept is very crucial. The basic concept of vector, this concept like data ingestion you have to create in RAG application. You should know embedding. Okay, you should know the query, how to do query. Okay, so this part is very central part. And then for RAG application, you have to build these pipelines. The first is the ingestion pipeline, the query pipeline, and you have to create a prompt. You should know the prompt engineering very well, because the response, the quality of response depends upon the quality of prompt, how good your prompt writing. Okay, and this is what LLM will process basis on the basis of prompt. So this is about the RAG. Okay, this is what happens in the RAG. In this video, I'm not covering very implementation part, how to implement this whole picture. Okay, my idea was to give you the basic idea that what is vector database, what is embedding, how the search happen, vectors. Okay, different pipelines. Okay, so these are the very basic concept I wanted to cover. Maybe in the next video I will give the implementation, how to create load data, chunking data, creating embedding. Okay, and then do a search and create some RAG kind of application. I will come with new video, maybe next video, and I will give more idea about implementation part. Okay, so this is all in this video. I hope you got a lot of value, got the basic idea. And please, if you like this video, please do subscribe my channel, because maybe next video I will more cover about implementation, like robot, like agentic framework, like agents, like there are multiple things happening in the Gen AI area, which I will cover in the next video. Okay, so this is all in this video. I hope you got a lot of clarity, got the basic concept about vector database, embedding, algorithms, search. This all thing that was my intention to cover in this video. This is Raj. I will come back with a more video. Till then, goodbye, take care, and keep learning. I will come back.